The Silent Spy, Wi-Fi-Based Positioning Systems and Global Privacy Risks by Sebastian Friedrich Nessler, a final project of Harvard's Gates, CS50 Cybersecurity, the 23rd of November 2024. I chose the topic of mass surveillance through Wi-Fi positioning systems as it aligns with topic 4, preserving privacy, from the lecture series. Additionally, it intersects with the field of network technology, which is an integral part of computer science. Based on a white paper from Eric Wright and Dave Levin, Maryland University, the 23rd of April, 2024. Introduction. Imagine walking through your daily life, a morning jog, a coffee shop visit, or a quiet evening at home. Now, picture this. Every Wi-Fi network you pass, every device you use, is quietly leaving a digital breadcrumb, traceable to anyone with the know-how to look. This isn't a scene from a dystopian movie, it's reality. Today, I'll unveil how Wi-Fi-based positioning systems, or WPS, expose us to unprecedented privacy risks. Specifically, I'll focus on Apple's WPS, a technology millions use daily without realizing its potential for misuse. This research demonstrates how attackers, without advanced skills or expensive tools, can exploit this system to track devices globally, map disaster zones, and even infiltrate sensitive conflict areas. I'll share real-world case studies, the technical anatomy of the exploit, and actionable solutions to address this looming threat. So let's begin with the foundation. How does WPS work? What is WPS? Wi-Fi-based positioning systems are the unsung heroes of our digital age. They enable your phone to pinpoint your location quickly, efficiently, and without draining your battery. Here's the magic. Devices like smartphones scan for nearby Wi-Fi networks and report the MAC addresses, technically known as Basic Service Set Identifiers, BSSIDs, of these networks, along with their GPS coordinates, to centralized databases run by companies like Apple and Google. Later, when a device queries the system, it doesn't need GPS to locate itself. The WPS database cross-references the Wi-Fi networks nearby and provides an approximate location. But what exactly is a MAC address, and how does it play a role here? A Media Access Control MAC address is a unique hardware identifier assigned to network interfaces for communication on the physical network segment. It is a 48-bit address, often represented in hexadecimal format, for example, 084A93-2FB107. In the context of Wi-Fi networks, the MAC address serves as a crucial Layer 2 data link identifier that ensures data is directed to the correct device on the same local network. When devices need to communicate across networks, Layer 3, network layer, MAC addresses interact with IP addresses through the Address Resolution Protocol, ARP. For example, if a device knows the IP address of another device but not its MAC address, it sends an ARP request across the local network. The device with the matching IP responds with its MAC address, enabling the transfer of data at the hardware level. In the case of WPS, the BSSID used for geolocation is derived from the MAC address of the Wi-Fi access point, linking this low-level hardware identifier to the broader geolocation system. Here's the problem. WPS wasn't designed with privacy as its priority. Apple's system, for example, doesn't just respond with the requested location, it returns data on up to 400 nearby networks. This overzealous functionality turns a simple query into a goldmine for attackers. The exploit, a global surveillance network. Now let's dissect how attackers exploit this vulnerability. Picture a hacker with nothing more than a laptop and access to Apple's WPS API. They don't need to be near the target. They don't need credentials. All they need is a list of possible BSSIDs. Using publicly available manufacturer identifiers, called OUIs, attackers can systematically generate valid BSSIDs for specific regions. When they query Apple's WPS, they not only get the geolocation of the requested Wi-Fi network, but also hundreds of additional nearby networks. In just 1 year, researchers used this method to geolocate over 2 billion Wi-Fi access points worldwide. This isn't a hypothetical risk, it's a blueprint for mass surveillance. Let me paint a picture of what this looks like in practice. Impact: stories of risk and vulnerability. 2. To truly understand the stakes, let's explore some real-world case studies. First, Ukraine and Gaza. In Ukraine, researchers tracked Wi-Fi devices moving into conflict zones, revealing activity in Russian-occupied territories. Starlink routers, critical for communication, were pinpointed, potentially exposing military operations. In Gaza, the aftermath of the conflict was eerily visible in Apple's WPS database. As power outages struck, Wi-Fi networks disappeared, painting a grim digital portrait of devastation. Next, Maui wildfires. During the tragic Maui wildfires, researchers observed Wi-Fi networks vanishing from Apple's database as homes and businesses were destroyed. These digital markers mirrored the physical impact, highlighting how attackers could exploit WPS for disaster assessment, or worse, targeting vulnerable areas. Finally, targeted tracking. Travel routers, often used by journalists, refugees, or military personnel, were traced across borders and continents. This ability to monitor individuals so precisely has chilling implications for human rights and personal safety. Each of these cases underscores how a seemingly benign technology can turn into a surveillance tool with global reach. Mitigation strategies, a call to responsibility. So how do we fix this? The responsibility falls on 3 key groups: operators, manufacturers, and users. For WPS operators like Apple, implement authentication for queries. Right now, anyone can access this data without verification. Stop including unrelated nearby Wi-Fi networks in responses. A query for one network should return data for that network only. Adopt regional restrictions to protect sensitive areas, such as war zones or disaster zones. For manufacturers of Wi-Fi devices, enable MAC address randomization for Wi-Fi access points, just as many mobile devices already do. Educate users about how their static device identifiers expose them to tracking. For users, regularly reboot or replace routers to refresh their MAC addresses. Avoid using static devices like travel routers, especially in sensitive locations. These actions collectively could drastically reduce the risk posed by WPS vulnerabilities. Conclusion: reclaiming privacy in a digital world. In closing, Wi-Fi-based positioning systems are an incredible tool, but they come at a steep cost to privacy. As we've seen, their current design prioritizes convenience over security, leaving billions of devices and their users vulnerable to exploitation. This research highlights an urgent need for reform. Operators must rethink their APIs. Manufacturers must adopt privacy by design principles, and as users, we must become more aware of how our devices interact with the world around us. Technology shapes our lives, but it's up to us to ensure that it does so responsibly. Privacy is not a luxury, it's a fundamental right. Thank you for your time and attention. I look forward to your questions.